Linear slides are pretty nice. They provide a pretty compact way to have an extension, such as the anti-tips in our tower takeover robot. However, the official Vex slides have some problems, namely increased friction and the ability to pull them apart pretty easily. However, there are some ways to use official Vex parts to create legal custom slides, and that's what we're going to cover here today. I'm Caden with Kepler Electronics, and let's get started. The first way that I'm going to cover is a way that I've already covered on this channel, but it does deserve a mention here. High-strength shafts are about the same size as standoffs, so they also fit through high-strength bearings with little slot. This allows us to screw standoffs to the bearing and run another standoff through the center with a stop, which allows us to double the length of the slide when extended. We use these in the center of our pull-apart wall bot to hold the center of the bot together and had very few problems. They're surprisingly strong. They do have a bit of twist in them, not to mention friction, but they are currently one of the lowest profile slides available. The other more complex option is to use C-channel. It's long and should work as a rail, right? Well, the idea here is to stick two pieces together like this, so that they can extend in this way. The problem is that we need something to hold them in place, and there aren't really any immediately apparent options available from Vex parts. So how can we make this work? These are some spacers that I bought from McMaster Car, though you can likely get similar ones from other places. They're the same interior diameter as the official Vex spacers, but have extremely thin walls. These spacers should be legal under Rule R11, which states that commercially available spacers are allowed if they are shorter than 2 inches. Some may argue that these, due to their smaller stature, break the added functionality rule, but I've seen teams use spacers like these for this purpose with no trouble. They're basically what you would get if you took the official nylon spacers and sanded them down or machined them on a lathe, both of which I have heard of teams doing. If you don't want to risk buying them, you can do this sanding or machining process, but it'll just take extra work and likely won't be quite as precise as the official ones. But let's get back to the actual slides. We first need to take some screws, put the spacers on, and then screw them into some holes. And that's really it to build a super basic version. Just slide the other piece of C-channel in, and there you go. The screw heads are very slightly wider than the spacers, and that helps prevent the rails from pulling apart. They still can be pulled apart, but that could be remedied in a number of ways. There's also a bit of friction due to the metal-on-metal contact, but it's surprisingly low with aluminum. If you need to decrease the friction even more, there are a number of legal greases such as white lithium grease. Here's one application where we have a fully self-contained system. We have 2 long rails which are standoff together, and 2 small rails which have the spacers necessary to keep the slides together. It does actually conform to the normal Vex hole pattern, which can make this style pretty nice for something like an anti-tip, as it'll be relatively easy to mount to your robot. This style is also completely captive, which solves the problem of pulling the slides apart. If the slides are sticking together, there is one easy thing to check. Check that the spacers aren't too wide. Another thing to check is that the spacers aren't screwed down too far, as this can increase friction and lead to the screw heads getting caught inside the notches on the C-channel. As you can see, there's a bit of wiggle in the screws here, but everything stays together and slides really well. The other benefit about this design is that they can stack right next to each other quite easily, which can be really nice for a cascade lift. If you're interested, I'll have a link to my video on cascade lifts in the description. It doesn't use this technique for the slides, but I think it does a pretty good job of explaining the basic mechanics. Thanks for watching, and aside from making videos on Vex designs, I also compete in combat robotics, so if you're interested, be sure to check out my video on Blastwave, my 1-pound combat robot. Thanks again for watching, and keep designing.